Hi, everybody. I hope you've had a good couple of days and that the movies and the homework, you've been able to get through those pretty easily. And we'll go about getting you ready for the test on Friday. So the screen in front of you says the Test 2 study guide, which I'm going to go over with you. Just some reminders. Please bring to the test your trig table, which is the green sheet, and then your SOHCAHTOA sheet, which is the yellow one with the color pictures on it. Remember, you can put notes on the front of the SOHCAHTOA sheet, not the back. And this is instead of a 3x5 card. So also bring a pencil and eraser. Things that will be provided are calculators. Phones will not be used or even seen during the test. And then also scratch paper. And another reminder, if you're not going to be here on Friday or you will have to leave early due to sports, please email me as soon as possible. I want to make sure we set up the time, the expected time for you to take the test if you're not going to take it on Friday. And because I don't want to leave this lagging if we have to wait until after the break. One person has contacted me, thank you very much, about not being here, and we've already set up a time to take the test and everything's good to go. You need to take the initiative to talk to me or to email me if you're not going to be there or if you're going to leave early. Okay. Otherwise, I get to decide when you take the test, which you might not want to do that. Okay. So I'm going to go through the study guide that you hopefully have in your hand, and I'm not going to do all the problems, but I will discuss each section, and if you have questions, you can email me. Okay. Okay, so number one, label the sides of the triangle by now. Or below. And hopefully by now this is not a problem. So the words I would like to see you use to label the triangle are hypotenuse, okay, adjacent, D, and opposite. Notice that your theta and the 90-degree sign are already done for you. Okay. So number two, write the ratios for each of the following functions. For this, you're going to need to know SOHCAHTOA. Okay. And so sine of theta, opposite over hypotenuse, cosine, adjacent over hypotenuse, tangent, opposite over adjacent. You just want to make sure that you know these. Okay. Number three, you're going to use your trig table to find the following values. If I give you the sine of a degree, then you need to use the trig table to find that value. And then if I say if sine theta equals 0.9945 or any number, then you can find the theta. So let me quickly. Oops, don't think I can do that. So hopefully, I was going to try to jump over to the trig tables, but hopefully that's not a problem for you, and we're just going to keep going. If you have a problem with the trig tables, let me know, and I'm sure Miss Lisa and Mr. T can help you also. Okay, number four, another type of question you might see. Tell whether the three numbers can be the measures of the sides of a triangle. Speaking of problems like this, going over the first quiz would be really helpful for you because about half of the questions on the test are taken from that first quiz or are going to be very similar to that first quiz, and half of them are going to be new from the stuff that we've already that we did over the past week and a half. So going over that quiz and making sure that you know how to do problems like the ones in number 4 and number 5 would really be helpful for you. Okay, so just in general, remember the way we tell whether the three numbers can be the measures of the sides of a triangle, we take each of the sides, add them together. So in the case of A, we're going to take 9 plus 8, which is 9 and 17 is greater than 7. Okay, 8 and 7 is 15, which is greater than 8 and 7, which is greater than 9. Okay, 9 plus 7 is 16, which is greater than 8. So yes, we have a triangle. And so please write yes. Okay. So make sure you write that yes. If you just write this, just write the numbers, I won't know if you have interpreted that correctly. So make sure you write yes or no, whatever the answer is. Okay, so number 5, tell whether the three numbers are the measures of the right sides of a right, obtuse, or acute triangle. Okay, let's take a look here. So remember, we go back and we use Pythagoras for that. A squared plus b squared is somehow related to c squared. Okay, so in this case, we have 3 times 3 is 9, plus 49 is related to the square root of 58. And I don't know what the square root of 58 is, but 9 plus 49 is going to be 9 and 8, 18 is 58. Okay. And c squared is going to be, c is going to be 58. Okay. Or sorry, c squared is going to be 58 because this is c, so we're using a, b, c. Okay, so because the square of the square root is the number inside. 58 equals 58, and therefore it is a right triangle because they are equal. Okay, and remember, if the a squared and b squared were greater than c squared, then it would be an acute angle, and if it was less than, then it would be an obtuse. So I'll write those down here. A squared plus b squared equals c squared for the right. A squared plus b squared greater than c squared for the obtuse. And for the acute, a squared plus b squared is less than c squared. Is that right? No, that's not right, is it? Boop. It's been a while. Okay, so a for the obtuse is less than. Okay, and then I'm spending too much time studying. Okay, sorry about that. Okay, so that's how you would do those types of problems. Okay, now number 6, without using trigonometry. Gosh darn it. Go back. Okay, without using trigonometry, find the missing sides for each triangle. Hint, remember the rules for special triangles. And remember, we talked about isosceles triangles being special. So that, again, my drawings aren't great, but you have this side. This is an isosceles triangle. Okay, the two sides are equal, and then the hypotenuse is equal to square root of 2 times one of the sides. Okay, and then we also learned about 30, 60, 90s. Okay, so this guy's a 30. This guy's a 60. Okay, remember the smallest leg was always x. The next largest leg was square root of 3 times x. and the hypotenuse is 2 times just x, okay? And so remember, we had to do various manipulations to figure that out, okay? So that's what you need to do in order to do these two. So let's look at the first one, 45, 45. So you know these are both going to be equal to b, okay? And you know this, okay, the hypotenuse, because it's across from the right angle, is going to be c. So you know you're going to have b squared plus b squared equals c squared. Okay. Oh, wait, you don't even need to do that, right? Okay. Oh, wait, yes you do. Haha. Because you don't know what x is, and you have to figure that out. So we know b squared plus b squared is equal to c squared, which is 5 times the square root of 2 squared. Okay, and we know this is b squared plus b squared is 2 times b squared. Okay, equals 5 times the square root of 2 squared. So 2b squared is going to equal to, remember we have to take this apart, so the whole number is 5, and we're going to square that, so that's 25, and then we square the square root of 2, so that's going to be equal to 2. So we have 2b squared is equal to 25 times 2 is 50. Okay, I'm going to divide both sides by 2 to isolate my b squared, and I'm going to have b squared is equal to 50 over 2, which is 25. Because remember, this goes away, and 50 divided by 2 is 25. So b squared has to be, or b has to be equal to 5. Because I take the square root of b, and I take the square root of 25, and the square root of 25 is b. Okay? So on our triangle, then, we have b is 5, b is 5, and sure enough, b times the square root of 2 is the hypotenuse. Okay, so that's, and you can do the 30, 60, 91 on your own. Again, if you need to go over this, go back to the quiz, okay, and look at it, because there were problems just like this on the quiz. Oh, here's your favorite, simplifying radicals. Ooh, okay, so square root of 48. I think we've talked about how the square root of 48 is super important that you remember, because it crops up everywhere. So, and remember there were several ways to do this, but let's try to factor 48 and see, 2 times 2 is 4, 2 times 24 is 48. Okay, we can break that down further. So 2 can't be broken down any further. 24 can be broken down into 2 times 12. Okay, and 12 can be broken down into 2 times 6. Okay, so we basically have square root of 2 times 2 times 2 times 6. Is that right? 2 times 4 times 2 is 8 times 6 is 48, right? Okay, so we have the square root of 2 squared times 2 times 6. Okay, so we can bring out our 2. So it's going to be 2 times 12. Okay, and 2 times 12 is the same thing as 2 times 2 times 3. So again, I can bring out another 2. So I'm going to have 4 times the square root of 3. Okay, so actually I could have gone up here, back here, and done 2 times 3, and that probably would have been a little smarter, but we got there either way. So there's a million ways you can solve these things, okay, as long as you get down to the same answer is just fine. Okay, and you have some other ones to practice there. Okay, now we have another simplification problem, and this one is features. You have a, gosh darn it, you have a radical in the denominator. And you all know by now that radical in the denominator is no bueno, and it's got to go. So, what do we do? And, come on. Okay. So it doesn't make dots very well. Okay. So we're going to take that, that radical, and we're going to multiply the whole fraction by the radical over the radical, which is just equal to 1, and we can multiply anything by 1 without changing anything. So we're going to end up with 5 times the square root of 20 squared on the bottom, with the square root of 15 times the square root of 20 on the top. Now that doesn't look very simplified, and you'd be right, because it's not. So we have some more steps to do. And so 15 times 20, let's see, 10 times 20 is 150, so that'd be 300. And then we have 5 times the square root of 20 squared, which is just 20. So 5 times 20 is 100. And 300 divided by 100 is 3. Imagine that. So that whole radical simplifies down to little old 3. So that's pretty neat. And that would be your answer. So again, the tricky part is remembering. I'm going to change colors. Taking the radical that's on the bottom, okay, and then multiplying the whole fraction by 1 in the form of the radical over the radical. Okay, and then we get that radical off the bottom because we're squaring a radical, so the radical goes away. And if we have radicals on the top, that's fine. Maybe they'll simplify to not have a radical, like in this problem, or maybe they won't, and that's fine. But the radical is not on the bottom, which is not fine. Okay. Next on the menu. So find the value of the trig function indicated. Write your ratio in the simplest form and rationalize when needed. So I'm just going to do the first one here. So we know from SOHCAHTOA, okay, we're working with a cosine. Okay, so cosine theta is going to be equal to the adjacent over the hypotenuse. Here is my hypotenuse, because it's across from the right angle, and my adjacent is going to be next to theta, so that's going to be 12. So my adjacent over the hypotenuse is equal to 12 over 12 times the square root of 5. I think we've seen this problem before. It's looking familiar. Okay, so 12 goes away, and we have 1 over the square root of 5. And remember, 12 divided by 12 is 1, and 1 goes on the top. I think some people were having some problems with that when we saw it before. Okay, so just like we talked about, we're going to take the radical in the bottom, and we're going to make a 1 out of it. So we're going to put a radical on top of the radical, And we're going to end up with 1 times the square root of 5. So square root of 5 over 5 times the square root, the square root of 5 squared is equal to 5. And that's my answer. I can't do anything more with that. I have a whole number on the bottom, which is fine. I have a radical on the top. That's fine. I'm done. Can't do anything else with it. Okay. Okay, solve the following triangles. So this is the stuff that you guys have been working on over the past couple days. And so I put a table here for you to use. And I think I want to change colors. We'll go to green. I haven't done green on this one. Okay. So in this case, when you're given this angle like that, this guy is going to be theta. Okay, so we can fill in our theta here. Our theta is 40 degrees. Okay, and this side is across from the right triangle, so it's going to be our hypotenuse. So our hypotenuse is 8. And so we have one angle and we have one side. So what do we do with that? So we need to find another, what shall we do first? Okay, we have 2 angles. So we have, well, let's label first. That was our first thing. So this is our hypotenuse. Here's our theta. So this is our adjacent. Okay, this is our opposite. So we've got all that labeled. We've got our table and we're ready to go. So we have 2 of the 3 angles. So all we need to do is add 40 degrees plus 90 degrees. It's 130 degrees. And what should all 3 angles end up being, or add together to be? That's 180. So we take 180, subtract that 130, and we end up with 50 degrees. Okay, so that other angle is 50 degrees. And then you can put it up here if you'd like. Okay, so now we have all 3 of our angles and we have one of our sides. So we need to find out our sides. I'm going to change colors. Go back to red, make it look like Christmas. So we need to find our opposite and our adjacent. So remember, SOHCAHTOA. Okay, which of the 3 functions uses opposite and adjacent? It's tangent. Okay. But wait, that won't help us, will it? Nope. Because we would have 2 unknowns, and we don't want 2 unknowns. So we have to be smart, and we have to pick one or the other. So which would I rather do? Would I rather do an opposite over a hypotenuse or an adjacent over a hypotenuse? Doesn't matter. Let's do an opposite over the hypotenuse, which would be sine theta. Okay, it's going to be equal to the opposite over the hypotenuse, which is 8. And my sine of theta is going to be sine of 40 degrees. And I'm going to have to go pause it while I calculate that. So hold on a second. Okay, I'm back. So the sine of 40 degrees is 0.64278. And because 8 is greater than 5, whereas 5 are greater, I'm going to have to round that 7 up. And so sine of 40 is 6428. So let's rewrite our equation. So I have 0.6428 is equal to the opposite over the hypotenuse. Okay, I want to isolate my opposite, so I'm going to have to multiply both sides by 8. Okay, this guy's going to go away. So I'm just left with the opposite. And if I multiply my sign by 8, six, 48. Okay, I get 5.14 is equal to the opposite. Yeah, and that kind of makes sense. So my opposite is going to be 5.14. So I've got one remaining problem here. Okay, so I'm going to erase. Because now I have two sides and I need my third. So I'm going to do 0.14 here. Okay, so I go back into good old Pythagoras. A squared plus b squared equals c squared. Okay. My a is going to be 5.14 squared plus b squared, which is my unknown, is equal to c squared, which is my hypotenuse, which is 8 squared. Okay. So 5.14 squared is equal to 26.44 plus b squared is equal to 8 squared is 64. Okay, I'm going to subtract 24.64. Hold on a second. So 64 minus 26.44 equals 37.56 b squared. And so b is going to be equal to the square root of 37.56. And you do not need to do anything with that. Okay, and you're done. Here's your table. Okay, that's what needs to be filled in to get full credit. Okay, so that's it. I think that's all the ones I'm going to go through. I think you can do the rest on your own. I take my exam tomorrow, and it's all day. It goes from like 8:30 to 3:30. And when I get out, I will put up answer keys for the last two homeworks and also for this study guide. So you'll be able to have that. Okay, so again, any questions, email or text me. Good luck on your studying. And so for the rest of your class today, please finish the study guide. Take advantage of Miss Lisa or Mr. T being there to help you. And I will see you on Thursday. Oh, and again, if you have a free 7th period, if you're in 6th period, but you have a free 7th period, and you want to come in during 7th period on Thursday to get some help, that'll be fine. So please feel free to do that. I will be there at lunch, but I have a meeting at 1 o'clock that I have to go to, so I'm going to have to leave at about 12:55 or something like that. So come in early at lunch if you want help on Thursday, and also I'll be available at lunch on Friday. Okay, so see you then. Good luck studying. Bye.